All right, in this video, we're still in Unit 1 of the basics of anatomy, and we'll be going over the concept of homeostasis in depth here. And so to begin, we will define what homeostasis is. Homeostasis is the ability of the body to maintain a relatively constant internal environment, regardless of the external environment. So regardless of what's going on outside of your body, the inside of the body is trying to remain normal, whatever that normal is for the particular organism. This is limited to more complex organisms because more complex organisms have more complex brains. This kind of maintenance requires complex brain function. Most creatures just adapt by taking on the characteristics of their environment. And so creatures able to maintain that constant internal system have been more successful as far as evolution is concerned. And so mammals are a great example of this, maintaining an internal temperature that is independent of the environment. And so the adaptations for mammals are adaptations that allow them to maintain that internal environment as opposed to just adapting to their environment. Because for some places in the world, for instance, where mammals live, it wouldn't be very good, particularly for humans. Humans live everywhere, cold, hot, whatever, and our bodies maintain that normal. Homeostasis is controlled through communication systems throughout the body. I'll stay right here for now. These factors that are regulated have to do with things like temperature, water balance, salt, pH. All these different things are monitored. You can see this on this picture. There are receptors that monitor those changes. So just like your nervous system works, there's some sort of stimulus that is going to produce a variable. You see there on the right or on the left, number one, and then there's receptors that receive that information from the outside. All right, and that is sent to the control center, which in this case is the brain. There is a part of your brain called the hypothalamus, and the hypothalamus receives all of that information concerning homeostasis. And it not only receives it, but then it determines what is the appropriate response for that stimulus. If it gets colder outside, the hypothalamus receives that information from your skin or wherever, and then decides, you know what, we should warm up. And then it's going to send a signal back out to the effector, which is the you see on the right, which elicits a response. And so in this case, it's cold. The effector is going to be the muscles. The muscles are going to start shivering, causing your body temperature to go up. And so you get how this works. There is a kind of a three-step process: receiving the information, the brain then doing something with that information, and when we get to the nervous system, we'll call that integrating that information, and then an effector causing the effector doing a response being caused by its input from the brain. There are two different ways this works. There's a system called negative feedback. Most homeostatic control mechanisms are negative feedback mechanisms. And the idea here is that they are reducing or stopping the effect of the stimulus in order to kind of prevent this severe changes in the body. We use the cold as an example of this. You walk outside and it's cold. The skin receives that information, sends it to the brain. The brain's like, I know what to do with this. And then the brain sends that message out to the muscles and then causes you to shiver. And so think about negative feedback is the way that I have defined it is that the product of the process turns off the process. All right. So what is the product of shivering? Warming up. What does warming up cause you to do? Stop shivering. All right. And so once that process has achieved its desired product, that process will then be turned off. There's no reason for you to continue shivering once your body temperature has gotten back up. The same can be said of sweating. Once you have cooled down sufficiently, your body will stop sweating. And so you kind of get the idea here. That is different from positive feedback. In a positive feedback system, the product actually enhances the process. It doesn't turn it off. It keeps it going on. In fact, it makes it work even more. Put a picture of a baby in utero, because a great example of this is, well, a couple of examples from this. The baby being born causes, there's a hormone that causes the contractions to be stimulated, and those contractions cause that hormone to be secreted more, which causes more contractions. Think of it as ramping up. Breastfeeding is another example. When the baby drinks milk, it causes the release of a hormone, which produces more milk, and you get the idea. It gets this positive feedback in which the stimulus causes the response to be ramped up. There's this kind of cascading effect that goes on, and it can continue on until that stimulus is stopped. And so when there's an imbalance in homeostasis, typically we talk about things that cause those imbalances. And so the most diseases cause an homeostatic imbalance. And homeostatic imbalance then increases the threat of disease. If your body is not able to maintain homeostasis, the threat of something being able to invade from the outside is heightened. Age also affects the efficiency of homeostasis. Systems have difficulty maintaining norms as you increase in age, which is going to increase your risk for illness at the same time. And so, older people, for instance, have trouble keeping warm because their balances are off. It has nothing to do with anything that's wrong with them necessarily. It's just the fact that their bodies are slowly breaking down. It's the whole process of entropy, which we learn about in AP Bio, and you probably learn about in chemistry as well. These feedback mechanisms break down over time. And when there's a major breakage in the feedback mechanisms, then there can be major problems. Heart disease is a great example of this, where the heart is no longer responding accordingly. Or fever is an example. Fever is used to actually get rid of toxins that are in the body, or invaders like a virus or bacteria. But it is possible for fever to kind of go out of control and the body being unable to cool itself down. And so there are examples of how these imbalances occur. Typically, when you think of being sick or anything like that, that causes these imbalances. It causes the homeostasis in your body to be off a little bit. And we all feel this when we're sick. And the body has ways, the immune system and different other ways that we're going to learn about, to right that when it becomes off.